In this video, we'll be looking at trapezoids and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So this is different than when we talked about parallelograms because we learned that parallelograms have to have two pairs of parallel sides. So a trapezoid is not a parallelogram, but it is a quadrilateral because it has four sides. The parallel sides of a trapezoid are called the bases, and the non-parallel sides are called the legs. So you can see these are labeled in the diagram below. B, C, and AD are the parallel sides, and they are the bases. BA and CD are not parallel, and they are called the legs. Specifically, we can have an isosceles trapezoid when the legs are congruent. So your two bases are still the bases because they're parallel, but those non-parallel sides, the legs, if they are marked as being congruent, then we know that that would be called an isosceles trapezoid. So think back to when we learned about isosceles triangles. We said that in an isosceles triangle, the base angles and the opposite sides from them were congruent to one another. So that will be something similar in our isosceles trapezoid. So if a trapezoid is isosceles, the legs are congruent. So we just saw that. Legs would be congruent. That'll be here. If a trapezoid has a pair of congruent base angles, it's also an isosceles trapezoid. So for example, if you knew that these two pink angles were congruent, those are the base angles, then it would be an isosceles. Or vice versa, if I had done, instead of those two bottom angles, if I had said these two angles were congruent, then also that would make it an isosceles triangle. So the base angles are just the angles that are connected with the base there. And then a trapezoid is isosceles if and only if the diagonals are congruent. So our last kind of special part about these is that when you create the diagonals in an isosceles trapezoid, these two green diagonals would have the same length. Now obviously we can see that this part right here is not quite as long as this part down here. So the diagonals are no longer bisecting like we saw in the parallelograms. However, the two green diagonals as a whole would be the same length. So if the entire diagonal was worth 20, then the other diagonal would also be worth 20. Whereas you can see that in a regular trapezoid, not necessarily isosceles, if I draw this diagonal, it's a lot shorter than if I draw this diagonal way down here. So that coming from the top left is a lot longer than coming from the bottom left. So we have that as a specific part of isosceles trapezoids. One other part of isosceles trapezoids that are special is they have something called a midsegment. So the midsegment of a trapezoid, think about like a midpoint or what midsegment might mean. M right here will be the midpoint of AD because we can see AM is congruent to MD. Similarly, N is congruent, BN is congruent to NC, which means that N was the midpoint on that leg. So when you knew that you had a trapezoid here because this base was congruent to this base, you're given that midsegment, the midsegment coming from those midpoints there. It'll be parallel to each base, and the length will be half the sum of the lengths of the bases. So what we mean by that is that if this length was 8 and this length was 12, if I take AB, so 8, plus DC, which was 12, and I divide it in half, then I'll get the length of the midsegment. Well, 8 plus 12 is 20, and 20 divided by 2 would be 10. So that means the length of this midsegment would be worth 10. So it's just the average of the top and bottom bases there. And that's for any trapezoid, not necessarily isosceles. Then our definition of a kite. So our kite is our other type of quadrilateral that again is not a parallelogram. It has two pairs of consecutive congruent sides, but the opposite sides are not parallel. So this does not have to be parallel to that. That's not going to happen here. We won't have any parallel sides. We do have these congruent parts though, so this top shorter side will be congruent to this bottom shorter side, and this top longer side is congruent to the bottom longer side here. So a theorem for a kite is that if a quadrilateral is a kite, then its diagonals are perpendicular. And this is just something that I feel like I remember just from like seeing what a picture of a kite would be. Normally a kite crosses there, and we get that like T shape. And we can clearly see that that is creating that 90-degree angle. If a quadrilateral is a kite, then exactly one pair of angles are congruent. So looking at this kite, well, if I look at this angle and then at this angle, the right angle looks a lot wider than my left angle does. So those are not the congruent angles. In a kite, this angle will be congruent to this angle. And so we can use that to help us figure out what some of the missing pieces are in a kite.